Teach me how to factor. 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 Factoring polynomials. Word problems. You heard? All right, so here's the deal. Factoring polynomials, the very first step we need to do is there a GCF? GCF it, right? Greatest common factor. All right, the very first thing we need is to make sure that that first term is positive. All right, so if not, we factor out a negative. All that means is change each of those term signs. And then the next thing we do is we see if it has two terms. If it's two terms, it quickly turns into is it a difference of squares? That's the only thing that it can break down into, all right? So simplest form would be difference of squares, where we did that video last time. So if you want to check that out, you can look at that. I'm going to shoot over here and say, is there four terms? If there are four terms, the very first thing you want to do is put in standard form, SF, standard form. That means highest exponent to lowest exponent to the constant, all right, in order by degree. And remember, you group term 1 with term 2. So this is term 1, this is term 2. You GCF that. And then you take term 3 and term 4, and you also GCF that. And then you should see that you have get common binomials. That was day 1, I believe, of factoring. And then 3 term is probably the worst, and that's the most common. I don't want to say it's the worst, it just is the most work. The very first thing we want to do is see if it's a perfect square trinomial, which is when we have those pretty numbers, even exponents, and we take the square root of the first term, take the square root of the third term, multiply those two answers together, and then double it to get that middle term. If it's not a perfect square, then we're going to go to, can it be factored into 2 binomials? And that's your X method. Remember, we had that X, and then we also had the X method with the AC on top and the B wedge on the bottom. And this was just the C and the X, or I'm sorry, the B term here, and we went from there. All right, so this is kind of a breakdown slide of how you want to be thinking when you factor things out completely. So here's a word problem. A rectangular stage set up in a theater has an area of 15x squared plus 3x minus 12 square feet. Complete or factor the polynomial completely. All right. So the very first thing is it's a rectangle. So that's good. And then we have a trinomial. So if you go back here, is it a perfect square trinomial? Or let's factor out the GCF first. I'm sorry, I'm getting ahead of myself. 15x squared plus 3x minus 12. What do they have in common? All right, so the first term is positive, so that's good. And then we have 15, 3, and 12. My smallest coefficient is 3, so the largest 3 can possibly be is 3. So it's 1 and 3 are my prime numbers for that coefficient. Does 3, my greatest factor, go into 15 evenly? Yep. Yep. And yep. So I have a GCF of 3. What is that going to do to these terms now? All right, we're going to divide that multiplier out. So these numbers are going to get smaller. What is 15 divided by 3? It's 5. X squared is tagging along because I didn't take any x's out. The middle term is going to be x. And that last term transforms into -4. And again, this is what we did last topic, is we just distributed it back in to make sure we did it right. If you want to check, I wouldn't, because it's going to take too much time. So ready? What do we have going on here? We have 3 terms. Is it a perfect square trinomial? Is 5 a good number to take the square root of? No. All right. So right away we know that that's not good. This negative sign is also not good because C has to be positive. So now what are we going to do? We're going to do that big X method. All right. So the AC wedge is on top. The B wedge is on the bottom. This is multiplying. This is adding. So let's take A. A is 5. Our C value is -4. What is 5 times -4? -20. Adds the middle term. Our middle term is 1x, or just 1, because we're doing coefficient stuff here. And remember, since we have an A, we just put the A with one of those x's because it's x squared. And we'll simplify those side wedges here in a second. So what multiplies to -20 and adds to 1? 20 has a couple factors, but I think we know the 2 closest factors are going to be 5 and 4. And because this AC value is negative, The big factor will be the bigger number because it's going to be this sign, which is positive. So our 5 is positive, our 4 is negative. Now let's just check our work. 5 times negative 4 is negative 20. And 5 plus negative 4 is positive 1. So now we are going to simplify these wedges on the side. 5 and 5, those will reduce to 1 over 1. And we're going to do bottoms up. So remember that x goes in front and that plus 1 goes in behind. Does this simplify? Nope. So bottoms up, we go 5x minus 4. All right, so this is the breakdown. Don't forget that you factored this out. You factored this down and you factored this down. So your final answer will be 3x plus 1, 5x minus 4. All right. Again, just be careful because x plus 1 has 2 terms, so it could be a difference of squares. We know it's difference, so this has to be a negative, and it's a positive, so we know that's good. Here's a negative, but we don't have an even exponent here. And 5 is not a pretty number, so that won't break down either. So we know that this is going to be our final polynomial completely factored. The area of a rectangle is 20x squared minus 27x minus 28. So they're giving us the length, right? So we have a rectangle here. It says it's 20x squared minus 27x minus 8. And they're giving us a side length of 4x plus 1. So we need to find out what binomial goes here. So the very first thing I would do is, you know that this term and this term have to multiply to get 20x. So 20 divided by 4 is 5. I have 1x. I need another x to make it the x squared. And then your last terms have to multiply to c. Well, if I have a positive 1, negative 8 divided by positive 1 is negative 8. So we know that that is going to be our length, and we can, or our width, and we can check it, remember, by doing our box method that we learned with the last topic. What's 4 times 5 is 20. X times x is x squared. 5x times 1 gets you 5x. Negative 8 times 4 is negative 32x. And then negative 8 times 1 gets you negative 8. And remember when we did this last time with that box, we combined like terms on that diagonal. And we're going to get negative 27x as our middle term, which is our middle term up here in the area. And then we have our 20x squared here. And we get our negative 8 in the back. All right. So again, I took my front values, 4x times 5x to get my front term. And I take my back numbers, negative 8 times 1 gets me negative 8. And all I did was really divide this by 1 and divided this by the 4x. All right. So I took these values and just divided by the A term, the front term, and then the C term with the back term. All right. So your final answer that we're looking for is that width is 5 times x minus 8. If we only knew x, right? They could tell us it and we could figure out what those dimensions are. A clothing store has a rectangular clearance section with a length that is twice the width. All right, so this says length is twice the width. All right. During a sale, that's what this statement is making, right? During a sale, the section is expanded to an area of 2w squared plus 19w plus 35. Why do you think they're using w? Because that's the width. Find the amount of the increase in length and width of the clearance section. All right. So what do they give us here? They give us a trinomial, right? So that trinomial could potentially do what? Break down into a perfect square trinomial. You actually know it's not a perfect square trinomial because they're telling you rectangle, but you also know it's not because 35 is not a pretty number and 2 is not a pretty number. All right. So what are we going to do here? Since we have 3 terms in standard form, we use that big X method. Again, A times C goes in top. the b in the bottom wedge. And again, we have an a value, so that's going to go in the side wedges, so we can simplify at the end. What is a? 2. What is c? 35. So what's 2 times 35? 70. What's my b term? Is 19. So what two factors of 70 add to 19? So I'm going to make my list over here. It's 1 and 70, 2 and 35, 5 and 14. So 3 and 4 do not go into 70 evenly. And then 7 and 10. And then how do we get the b value? We add these up. And we get 71, 37, 19, and 17. So these are all possible b values. Which one are they telling me to pay attention to? 5 and 14. So once you get those side wedges, we try to simplify here. Can we simplify 2w and 5? No. So that's going to go bottoms up. And then 14 and 2, that will simplify to 7 over 1w. Bottoms up, we get w plus 7. So again, if we look here, here's this 2w. It's showing up right here. So this is my length, and this is my width. How do you know that? Because that 2w is your length. The length is twice the width. That's what it's telling us. All right, so we can get that area right there, length times width, and it's going to equal this trinomial up here. Any questions? Again, pause it, rewind it, make sure you listen, and then you can ask questions, email, speak up in class. The area of a square garden is 36x squared minus 60x plus 25. What is the perimeter of the garden if x equals 3 feet? So here's the key. You have a trinomial, and it's called a square. So guess what? It makes a square, meaning all these sides are equal. So it's sides squared. So how do we do that? Real simple. We take our first term. Oops, I'm doing the last one still. 36x squared, and we square root that term, and we get 6x. We take the third term, and we square root that, and we get 5. We're going to multiply those. We get 6 times 5 is 30. X is tagging along, and then we double it to make sure that this works, and we get 60x, which is our middle term. So remember, when we do this, this has to be positive, and then that negative for the b value will be what's inside my perfect square trinomial. This is my first term, 6x. My third term was the square root of 25, which is 5. And then we square it. All right. So the side squared is going to be 6x minus 5. Now, they gave us some detail. What's that detail? X is 3. So they also want the perimeter. So what they're going to tell us now is plug this in. We get 6 times 3 minus 5. So what's 6 times 3 is 18. 18 minus 5 gets you a side length of 13. What does perimeter mean? All the sides added up. So what's 13 plus 13 plus 13 plus 13? Well, 13 plus 13 is 26. 26 doubled is... The perimeter equals 52 feet. All right, so we used the perfect square trinomial to get us the length of one side, and then we substituted in that 3 for x. 6 times 3 was 18. 18 minus 5 is 13. And then we added up all the sides because perimeter is all the sides added up, and we got it to equal 52 feet. All right. An antique Persian rug. I always love these kind of questions because it's like, holy cow, antique Persian rug. Okay, maybe one day I can afford that. Has an area of x squared plus x minus 20 feet squared and a length of x plus 5 feet. The rug is displayed on a wall in a museum. The wall has a width of x plus 2 feet and an area of x squared plus 17x plus 30 feet squared. Write expressions for the length and the width of both the rug and the wall. Then find the dimensions of the rug and the wall if x equals 20 feet. Hint, area equals length times width. Whew. Exactly. All right, so that's why we're going to go over this together, because there's a whole lot of stuff to go on here, right? So the first thing we're going to do is this first part. If we have x squared plus x minus 20 and the length, so they're giving us half of our answer here, right? We just need to be smart and calculate the other half. So how do we do that? We said it's x plus 5. So how do you go from x times what gets you x squared? X. And if this is positive 5, how do you get negative 20 divided by 5 is negative 4. So we just found out if this is the length, this is the width. And that's of the rug. So this is x minus 4. And that's for the rug, right? And now for the wall, it's at x squared plus 17x plus 30. We need to break this down, and they gave us half that answer, x plus 2. So that front term, what's x squared? What? X times what gets you x squared? Obviously is x times x, right? And then 30, the last term, divided by the second term. What's 30 divided by 2? Is 15. So we know the length of this wall is going to be x plus 15. And obviously that's going to be larger because the wall is larger than the rug. So we did this part in green. And now it says write the expression for the length. The expression doesn't include equal signs, obviously. So that's what we have here and here. We have our expressions. And then the last thing they're going to ask us to do is find the dimensions of the rug and the wall if x is 20. So what do you need to do? Wherever you see x, plug in 20. So you're going to get 20 plus 5 and 20 minus 4. We'll simplify. 20 plus 5 is 25 by 16 feet, right? And then over here, we're going to plug in 20 plus 2, and we're going to get 22 feet by 35 feet. So here's the dimensions of the wall versus the dimensions of the rug. And that makes sense because this clearly has more area than that over there. Any questions? So they're looking for the dimensions. So all we did, wherever we had x, we plugged in 20 because that's what it told us. All right. So again, blue was the first step. Green, I highlighted did it in green, not highlighted in green. And then the last step I did in red. Any questions? Again, pause it, rewind it. If you have questions, shoot us an email. Say, hey, I have a question on this one. Perfect. We'll help you out. The area of a poster board is x squared plus 3x minus 10 square inches. The width is x minus 2. So they keep giving us half of that information, which is fantastic, right? So we have x squared plus 3x minus 10. I could solve that by using the x method, right? What multiplies negative 10 and adds 3? But why do you think if they're giving us half the answer? How do you get the second half? What's the front term? The front term is x squared. So x times what get you x squared? That's going to be x squared. Or x, sorry. And then negative 10 divided by negative 2 gets us positive 5. And now you can do the inside. What's negative 2 times x is negative 2. The outside, what's 5 times x? 5x. What's 5x minus 2x? Positive 3x, which is our middle term. So you can do this and check it real quick. So here's your expression for the length of the poster board. This is your length. This is your width. How do we get the width? That was part of our problem. Find the dimensions of the poster board when x is 14. So again, we're plugging in 14 minus 2, and then 14 plus 5, giving us our dimensions of 12 by 19. Okay, and that's going to be inches because that's what it says in this problem here, inches. Write the polynomial for the area of the poster board if 1 inch is removed. So this is kind of a cool question. If we remove an inch, what does that look like? All right, it says write the polynomial. So it doesn't want 11 by 18. It wants you to rewrite the polynomial. So how would you do that? Well, instead of saying x minus 2, it'd be x minus 3. And this would be x plus 5, take away 1, is x plus 4. So that's in binomial form. If you want it in polynomial form, as far as a trinomial, double distribute, x times x is x squared. We get x go deep plus 4x. X times 4x is 4x. Double distribute, negative 3 times x is negative 3x. And then that last hump would be negative 3 times 4, getting you, negative 12. Combine like terms, which are our x's in the middle. X squared plus x minus 12 would be your trinomial, which is equal to your binomial times a binomial. So if it needs polynomial form, I'm going to assume it's x squared plus x minus 12. However, if you left it in binomial form, I guess, right? That's just going to be factored down. Any questions? Again, please pause, rewind, and we'll help you out there. Last thing, I'm finished. That's my SpongeBob sound. I don't know. It doesn't sound anything like it. All right. If you liked it, again, subscribe, thumbs up, and shout out to one of my virtual students for taking all of my intros, the crazy sounds I make at the beginning, and meshing it together into one nice video. Other than that, I appreciate that, Leon. And of course, go Browns.